after completing the dot product, cross product, and then understanding the concept of vector, we'll discuss about three-dimensional geometry today. Okay, so first we'll start with the plane. We'll start with the lines. Okay, a line in 3D. Okay, so you know there is something called two dimension, like one dimension, or there is no dimension. Let us say a point. A point does not have any dimension. I mean, it's zero dimension because it does not have a length, it does not have a breadth, does not have a height. So point zero dimension. Line, it has a single dimension. Okay, it has only length is there, no breadth and height. So plane, it is two dimension. Okay, the plane is two dimension. Then you have three dimension where you have length, breadth and height. Okay, so practically when we see the anything in space, practically everything is three dimension. Like whatever we see, the practically whatever we see, it is three dimension. Okay, so after completing the concept of vectors, okay, so vectors are basically the lines. Okay, lines having the direction. Okay, then in vectors we have discussed about addition of vectors, subtraction of vectors, multiplication of vectors. So using those concepts, how do we use those concepts in three-dimensional geometry to find the distance between two lines in space? Suppose I want to find the distance between two lines in space. How do I use those concepts of dot product, cross product to find the distance between two lines or angle between two lines in space? There are many concepts in three-dimensional geometry. Using these concepts that we have studied, how we'll find some useful informations. How we'll find some useful information in three dimension using this dot product, cross product, or the concept of vectors. How do we derive it? Okay. You have in your coordinate geometry, you might have already covered the equation of a circle, equation of a ellipse, equation of a parabola, equation of a hyperbola. So those things you have already, and the equation of a line, like say y is equal to mx plus c, and all that you have already derived. Okay.
Yes.
So and also if you know 2 points, like say let's say x1 y1, x2 y2. If you know 2 points, how do you knowing 2 points, how do you write the equation of a line? Okay. So you may be knowing like this, suppose x1 x2 x1 y1 and another point is x2 y2.
y2 minus
So
y1.
you know that the slope of the line will be y2 minus y1 by x2 minus x1. So how do we write the equation of line? So equation of line means any point equation of line means what? You are defining the dependent variable in terms of the independent variable.
Yes.
So any equation means you are writing the dependent variable in terms of independent variable. Okay. Let us say we are saying equation of a circle is equal to x square plus y square x square plus y square is equal to r square. So if you know the radius of the circle, then x square plus y square is equal to r square. So that means x and y are any point on the circle. So any point on the circle, if you know and the radius of the circle you know, then you can write the equation of a circle. Okay, so here it is nothing but a relationship between y and x. R is a constant. The relationship between y and x.
Between the 2 points.
So y may be a dependent variable, x may be a independent variable. Similarly, equation of a line, y is equal to mx plus c. So that means you are writing y in terms of x. Okay.
Slope is constant.
So something like, let us just start with that. How do we write that? So let us say this is my circle. Okay. So at any any point in the circle has coordinate x, y. Why? Because this is x, this is y. Okay, right? So this coordinate of so the coordinate of this point is x. So this is x, this is y, right? And the radius of this circle is r. Okay. So the equation of circle becomes x square plus y square is equal to r square. Okay.
Yes.
That means you can write y is equal to r square minus x square root. Right?
Yes.
Right? So this becomes a relationship y as a function of x. So y, the dependent variable as a function of independent variable gives you the equation of circle here. And let us say equation of line. Let us say my line, this is my this is a straight line. Okay. So like say I know any coordinate of this line is xy. Okay. So how do we write the equation of this line? So this equation of this line is y is equal to mx plus c. So if you ask what is m is nothing but the slope of this line. Okay. M is nothing but the slope of this line, and what is c? C is the y intercept. Why it is called y intercept? Because if I make x is equal to 0, y is equal to c when x is equal to 0. So this value is nothing but your c. Or y intercept. Okay. So that means this is also, this you have written as y as a function of x. Right?
Yes,
Y as a function. So any dependent variable in terms of independent variable, you are able to write the equation of a line. Okay. So then there can be different forms of equation of line. Okay. Suppose you want to write it in a different format. Suppose you know 2 points in a line, right? Let us say I know 2 points in a line. Okay. So this is a line. Okay. Then let us say point 2, let us say point 1. Okay.
Yeah.
So 2 points x1, y1 and x2, y2. Okay. So we know the slope of this line will be what? Because,
y2 minus y1.
So the slope of this line will be like say slope we write as m. It is nothing but if I move in x direction, in y direction how much I am moving?
Yeah.
What is slope? Like say you have a stairs. Okay. So these are your slopes, right? So by moving while moving x distance, how much I am moving in the y direction?
That is slope.
For given x, if I am moving more in y direction, that means slope is more.
Yes.
Right? Suppose I have first the same distance, I am moving very too much.
Slope will
that
be
means
higher.
this is very slope is very high, and you have to spend more energy. So that's why it's very steep.
Steep.
Okay, yeah. So what is the slope here? Slope is for delta x, what is the delta y? For a given delta x, what is the delta y? So m in this case will be let me write delta y divided by delta x, which is nothing but your y2 minus y1 divided by x2 minus x1. So you know this is my slope.
Yeah.
Okay. So this is a known slope. Okay.
Yeah,
then let us say that there is another point xy here. Because I have to write the equation in terms of xy, not x2, y2 or x1, y1. Those are known points. I have to write in terms of the unknown points, which is generalized one. So another slope here will become y minus y1 divided by x minus x1. Right? This is also a slope. Right?
Yeah.
So this is a slope, the m1, this is a slope m2. So these two have to be equal.
Yes.
Because it is the same slope.
Of the same
Only the point is different, but the slope, the angle will remain the same. So this equation of this line will become like y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So this is another form of equation of a straight line. Okay. So this is another, and then another form of equation of straight line is this. Suppose line is like this.
Other way.
Okay. So in this case, the this x intercept will be a, y intercept will be b. Okay.
Okay.
In this form. So the equation of straight
X
line
by
is
A
x
plus
by
Y.
a plus y by b is equal to 1. Okay. So why is it so? Because if you make y is equal to 0, let us say at this origin, okay, here here your when y is equal to 0, x is equal to a. Let us say at this point, okay, here y is equal to 0, then x by a will be becoming 1, so
is
x
equal
will become equal to a. Okay. And when x is equal to 0, like say you come to this point.
Y is equal to
No, you come to this point. Let us say this is point 1, this is point 2.
Okay.
At point 2, y is equal to 0. At point 2, this is the point 2.
Y is
At point 2, y is equal to 0, that's why x is equal to a. At point 1,
X is
y is equal to 0. Here.
Yes.
Sorry, at this point, x is equal to 0. X is equal to 0, that is why y is equal to b. Okay. So, in this case, so how do you get x and y intercept? By making x is equal to 0 or y is equal to 0. So, you got your x and y intercept to be a and b. Okay. So, then your equation becomes x by a plus y by b is equal to 1. So, that is also equation of a straight line. So, I have shown you there are three equations of a straight line, like capital A, this is 1, then this is capital B, this is 2, then another one we have studied, this is 1, right, y2 minus y1, yeah, so and another one, x, y, this is C. So these are three equations of a straight line. X by a plus y by b is equal to 1. Y2 minus y1 by x2 minus x1 is equal to y minus y1 divided by x minus x1. That is another equation of a straight line. And so what you can see from here? What is your general observation? Like you can see that this y is a function, linear function of x, because the power of x is 1 here. Okay. So when the power of x is 1, it is called a linear equation.
Yeah.
Okay. Because you can draw a graph and find it out actually. Suppose let us say y is equal to 4x. What does it mean? When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 4. When x is equal to 2, y is equal to 8. Like this, if you draw a graph between y and x, so it is when x is equal to 0, y is equal to 0. So this is the point. Okay. When x is equal to 1, y is equal to 4. Let us say this is the point. When x is equal to 2, y is equal to 8. Let us say this is the point. So it will be a straight line passing through these points.
Yeah.
Okay. So when the power of x is equal to 1, that is called a
linear
linear equation, linear function.
Yeah.
Okay. But you have seen a circle. So it is a straight line. But is this circle a straight line?
No.
It is not a straight line. So y square is equal to y square plus x square is equal to r square.
It is a curve.
Okay. So y square is equal to r square minus x square. That means here y is a is not a linear function.
Quadratic equation.
It's a quadratic equation or it's not a linear function. So this is the equation of a circle. Yeah. Then you might have studied about the conic sections. Okay, yeah. Conic sections, parabola, hyperbola, and circle also, ellipse. Three things you have studied. So you know you have studied about ellipse. Okay. So your ellipse, it's not the proper picture. Let me draw it the proper picture of a ellipse.
X square by A square plus Y square.
X square by A square plus Y. So the circle is a specific case of ellipse. Okay, the circle is a particular case. So ellipse circle is also a ellipse. Okay, when A and B are equal.
Yeah.
Okay, so
Coordinates of that are.
yes. So let us say this is this thing, and let us say this is a ellipse. Okay. So ellipse will have a major axis and will have a minor axis. So let us say the major axis A, the minor axis B. Okay. So the equation of a ellipse is x square plus A square plus Y square plus B square is equal to 1. So this is the equation of a ellipse. Okay. So if A is equal to B, what will happen? It become x square by A square plus Y square by A square is equal to 1 because A is equal to B. So in that case it will become A square plus Y square is equal to A square. So this becomes a circle.
A square is nothing
so
but
the ellipse becomes a circle.
Yeah.
Okay. Similarly, the equation of a parabola. Okay.
Y is equal to.
So let us say the equation of a parabola looks like this. Okay. So this is my parabola. So sorry, this is my parabola. It will look like this. So what is the equation of a parabola or a conic section? Y square is equal to 4ax. Okay.
Yes.
So what is happening? So
Focal directrix.
So for every x, for positive x and for negative x, it will y will be always positive.
Square,
okay.
because of square.
Because of square. So for whether it is positive x or whether it is negative x, y will be always positive. Okay. So y square is equal to 4ax is the equation of a parabola. Okay. Similarly, you have hyperbola and other things that you can study. So these are called conic sections.
Hyperbola is same but only minus instead of plus in place of
ellipse. Let me put it like this. So no, actually it is not like for every x. Yeah. So y can be negative also. For a positive x, y can be negative. That's the equation of it. Here you can see now y is negative.
in this one.
In this case, you can say y is negative. Y square is
square is positive.
Y can be negative also. Okay. So the
coordinate of y can be negative, but then the equation because of y square it will become positive.
Y square can be positive, but y can be negative because square root of a positive number can also be negative, right?
Yeah.
So here you are what you are writing? Y is equal to square root of 4ax. Okay.
If that is negative, then y becomes negative. Yes, understood.
So it can be positive also, it can be negative also. See, so square root of 4, right? Square root of 4 can be plus or minus 2.
Yeah. When you take square root, you have to take both.
So when you take here also, here you take. You imagine my x is 2 here. Okay. 2 means and in this case, because it is starting from origin, a is equal to 0. Okay. When it starts from origin, a will be equal to 0. When it starts from any other point, a will have some value.
Yeah.
Right. The parabola can also start from here also. So in that case, a will have a different value.
Here it is at origin.
So here it is
touching by x.
So here a is not 0, a is 1. In this case, y square is equal to 4x. 4x. So 4x, let us say x is equal to 2, right? When x is equal to 2, y square is equal to 8.
4 into 1 into 2.
4 into 2 is 8.
Yeah, 1
so
a
y,
is 1.
Y will become square root of 8. So it will 2
plus
into
or
root
minus
2. So
2
plus or minus 2 into root 2. So it can be here also, it can be here also.
Understood.
Is it clear?
Yes.
So I have covered equation of straight line, equation of conic sections, and so you know that there is something called linear equation, there is something called quadratic equation. Okay. Power, like let's say you know polynomials, na? Yeah. Polynomial is the most generalized form. Okay. Like say a0 into xm plus a1 into x to the power m minus 1 plus a2 into x to the power m minus 2, like that. It will go on, like say, a0, then a to the power 1, a to the power 2, so that the total power will become m. So here this is just a to the power 0 means 1. Anything to the power 0 is 1. So a to the power 0 into xm, a to the power 1 into x to the power m minus 1, a to the power 2 into x to the power m minus 2. Like this it will go on and then it will become a to the power m into x to the power 0. So this term, whatever, this is the equation of a polynomial. So can be 0 or whatever. So it's the equation of a polynomial.
Function of x.
So polynomial, it is like a, any power of x you can consider, so, but the total power is m. See, the power of add m plus 0, m minus 1 plus
First
power of a,
yeah.
that is also m. So this is a polynomial
With power m.
Yes,
understood.
So that's how you have studied the binomial theorem also. Like you have studied x plus y to the power m. So you know it will start with x to the power m, then x to the power m minus 1 into y plus x to the power m minus 2 into y square. Like that you have studied binomial theorem. The total power will become m. Okay, that's binomial theorem, and this is a polynomial.
Take the first term and make it last term also the same.
So the simplifying a polynomial, it will become a quadratic equation, like ax square plus
where
bx
m
plus
is
c.
2 is quadratic
equation. Then you have cubic equation. You have like that. If it x to the power q means it will be a cubic equation, like that. Okay. So
power 3 is cubic, power 4 is biquadratic.
So like this, with this introduction, you just remember this thing. This will help you to solve any equation on straight line, circle, conic sections and all. So you just remember circle is a special case of parabola, ellipse.
Where a and b
when major and minor axis are same. So major axis is the bigger axis, minor axis is the smaller axis. Okay.
Yes.
So you can take a picture of this. Okay. So the straight line can have three different equations. Like one is y minus y1 by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. And you can have, knowing the x and y intercept, you can have another equation which is x by a plus y by b is equal to 1. And knowing the slope and intercept, you can write the equation y is equal to mx plus c. So these are three equations of straight line. Similarly, your equation of a circle is x square plus y square is equal to r square, where x and y are coordinate of any point in the circle. R is the radius of circle. So circle is a special case of ellipse, and conic sections can be either parabola, it can be hyperbola, it can be ellipse, it can be any of them. Okay. So that is a relationship between when the relationship is not linear, it will become something like a conic section. Okay. Okay, understood?
Yes.
You can write these things also. Okay.
Yes, I wrote.
So we have discussed about lines, we have discussed about parabola, hyperbola, ellipse, circle, And why we have started it, because we are about to start three-dimensional geometry or 3D geometry. So in 3D geometry, we start with the line first, then we go to the plane. Okay. So we were telling that point is zero dimensional, line is one dimension, plane is two dimension, and a point can be anywhere in the space in three dimension. Okay. I was explaining in vector like a point x, a point P can have coordinate x, y, and z.
Right.
So it will have three coordinates like with respect to origin, what is the x distance? With respect to origin, what is the y distance? With respect to origin, what is the z distance? Okay. Uh, so let us draw it. Okay. Okay. So let it be like this. Let it be like this. Okay. So let me say this is my x-axis, this is my y-axis, and this is my z-axis. Okay. So let me say you imagine there is a point which is not in this plane, which is not in this plane, and it is not in yz plane. This is in x direction is perpendicular to the board.
Okay, this is ZY plane.
This is ZY plane. So imagine a point which is not in ZY plane.
Okay.
Okay. It is in X, Y, Z plane. Okay. Just little above the YZ plane.
In all three
So
places.
that it will have an X coordinate also. So let us draw like just let us draw a cuboid or this. Okay. So let's just draw it like this. Okay. Then why I am drawing it all that? Because in our time our teachers did not have this PowerPoint and projectors and slides. So drawing it will make you have a deeper understanding of what you are doing. Rather than just putting a slide, it does not solve the purpose. It does not make you understand. Okay, that's why our teacher used to use blackboard. Okay. 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 So now you can see a 3D cube kind of stuff, right? What do you call a cuboid, the parallel of cuboid, what do you call? What do you call in English? A cube. A square we call cuboid. A rectangle, what do we call?
Cuboid.
No.
Square we call cube.
Cube you call cuboid. Rectangle what you call?
Rectangle is cuboid. Square is cube.
Okay, cuboid. So this is a cuboid. Okay.
Because the faces are rectangles in a cuboid.
Okay, fine, fine. So this is a cuboid, right? Right?
Yes, yes.
So this is a cuboid. Okay.
4 faces are rectangles, 2 are cube.
Okay. So this is a cuboid. So let us take a point P here. This is the point P. Okay. So let me draw a line passing through P. Okay. Let me draw a line L passing through P. So it is not in YZ plane. Remember,
XYZ
if it passes through P, it is not in YZ plane. It is in XYZ plane. So let me draw a plane, because when we draw in blackboard we cannot represent the 3D. That's why sometimes
outside
it will be
perpendicular plane.
Sometimes it will be difficult for you to visualize. But just imagine you are drawing a line L which passes through point P.
Which is in XYZ plane.
It passes through point P. Okay. So when it happens, actually this line makes an angle this line makes an angle gamma, alpha. The angle made by line L with x-axis is alpha. Okay. The angle made by line L with y-axis is beta.
Okay.
Okay. The angle made by line with x-axis is alpha. So there are 3 angles.
Is gamma.
Alpha, beta,
The
x,
first
y,
one
z.
is
So this is z. So this is gamma. So you are making 3 different angles. Okay. Then you have point P and all this. Okay. So let A, B, C are direction ratio of a line. Let L and B are direction cosines. Okay. So direction ratio and direction cosines. Okay. So you know earlier we have studied about direction cosines.
Yeah.
Okay. So we are telling cos alpha is equal to
L.
what is that?
L.
L is equal to x coordinate divided by x square plus y square plus z square. That's what we have studied.
Yes.
Na?
Yes.
That is the cos alpha, which is otherwise called as direction cosine. That is L.
X by R.
So in this case, let A, B, C are the direction ratio of the line. Like suppose it will have a magnitude. Okay, so that direction ratio A is, if you multiply direction cosine with direction ratio, you will get the actual magnitude. Okay. So let us say L by A. Okay, L by A. Then M by B. M by B is equal to N by C. Okay.
This is for what? L by A.
Let us what he has given. Let me see. So, okay. If a given line in space does not pass through the origin, then in order to find its direction cosine, suppose it is not passing through origin, direction cosine, we draw a line through the origin parallel to the given line. Okay. Suppose here it is passing through origin. Okay. Suppose another line it is not passing through the origin.
Yeah,
So how will define it? So a given line. We draw a line through the origin parallel to the given line. So this is a line. So I will draw a line just parallel to this line. Okay. So maybe these two are parallel, right? So this is a line. This is another line which are parallel to the given line. Now take one of the direction lines from the origin and find the direction cosines as two parallel lines have same set of direction cosine.
Yeah.
So
because angle they make will be the same.
okay. So any three numbers which are proportional to the direction cosines are, of a line are called direction ratios of the line. So LMN are direction cosines we have already given. A, B, C are direction ratios. Okay. So any three numbers which are proportional to the direction cosines.
A, B and C are direction ratios.
So three numbers which are proportional to the direction cosines of a line are called direction ratios. Okay. So So L, M, N are direction cosines that you have understood. Okay, L, M, N or direction cosines. And then what is direction ratio? Any three numbers which are proportional to the direction cosines of a line are called direction ratios. Okay, so A is equal to some constant into L. Okay, then B is equal to lambda into M. Okay. C is equal to lambda into N. Okay. So, any three numbers which are proportional to direction cosine. Okay. So you find a number which is proportional to your direction cosine. Okay. If your
that
cost
will be
is
direction ratio.
these are called direction ratio. Okay. So any number which is proportional to the direction cosine is called direction ratio. So you multiply, like A is directly proportional to L. Okay, this is direction ratio.
That lambda will be the proportion.
B directly proportional to M, C directly proportional to N. So this A can be written as lambda L, B can be written as lambda M, C can be written as lambda N. So this ABC are direction ratios. Direction ratios. Okay. You can find out like corresponding to A direct. Suppose you find out a direction ratio which is proportional to your direction cosine. So A is directly proportional to L. So A is equal to lambda L. Let us say that is a constant. Okay. So in that case, what will become? L by A is equal to M by B is equal to N by C, which is a constant. Okay. If that is the case, lambda L is equal to become AK, M will be equal to BK, N will be equal to CK, like that. Okay. So then we know L square plus M square plus N square is equal to 1. That is well known like first.
We did that last chapter.
So in that case, K square into A square, so L square plus M square plus N square is equal to 1 and L is equal to AK. So L square plus M square plus N square is equal to 1. Then L is equal to AK, so it will become
A square, K square plus
K square into A square plus B square plus C square is equal to 1. And then you will find K is equal to 1 by A square plus B square plus C square square root. So this is your K value. Okay.
K is that proportionality.
Proportionality constant. Hence the direction cosines is So from this you can find the direction cosine is equal to a by a square plus b square plus c square. Okay. So this is same as what we have done x by direction
X square
cosine.
plus
That
y.
unit vector thing what we are doing na. The vector divided by a
Here we
square
were
plus.
taking term of coordinate, here we are taking term of that
Uh-huh.
proportionality.
Yeah. That's all. So there is not much, not nothing complicated here. Plus or minus. Then am is equal to b by plus or minus a square plus b square plus c square. Okay. Then n is equal to plus or minus c by a square plus b square plus c square. Okay. So these are all your direction cosines. That's how you write. Okay. Then we have already done that relationship between direction cosines of a line. Okay. So relationship between direction cosines of a line. This is another important thing. Okay, so relationship between direction cosines of a line we have already done. That is L square plus M square plus N square square root is equal to 1. This is the relationship between
Yes.
direction cosine. I am not deriving it. I am just writing it. Okay.
Yeah.
Okay. Then direction cosines of a line passing through 2 points. Okay. So a direction cosine of a line passing through 2 point in 3D. Okay. So what will be the direction cosine of a line passing through 3 points? Okay. So cos alpha, cos beta, cos gamma. Okay. So let us say this is this is my 3D. Okay. So let us say this is my PQ line. Okay. So it will have three different angles. Okay. Like say with the z axis how much angle it is making. So this is y, this is z, this is x, right? So this is p, this is q. Okay. So with z axis it will make angle gamma. Okay. With z axis it will make angle gamma. That you can see when you project it in the yz plane, you can see with z axis it is making angle gamma. Similarly, when you project it in xz plane, when you project it in xy plane, you can find other two angles also.
Yes.
Okay, so alpha, beta, gamma you can find out. Okay, so when you do this projection, so here what is happening? You have projected into yz plane. Okay, so this point will have z2 and y2 as its coordinate. Sorry, y2 and z2, not z2 and y2, y2 and z2. Okay.
Yeah.
And this point will have y1 and z1 as your coordinate, right?
Yes.
This point.
This
So
is in zy plane.
z1 plane. Your cos gamma. So your cos gamma will become equal to z2 minus z1 by the this your h hypotenuse. What do you tell?
Hypotenuse.
So cos gamma is equal to z2 by z1 by your r, right? This distance, or you can say z2 minus z1 by pq,
Which is r.
which is r. So that is the direction cosine. Okay. So this is for cos gamma. Okay. Similarly, cos alpha you can make it as x2 minus x1 by pq, and cos beta you can say y2 minus y1 by pq. So you know your cos alpha, which is L,
For x.
cos beta is M, cos gamma is N. So L, M and N will be like say my L is equal to x2 minus x1 by pq, my M is equal to y2 minus y1 by pq, my N is equal to z2 minus z1 by pq. So knowing all this L, M and N, I can take the square, then I know L square plus M square plus N square is equal to 1. That means what will become So if you simplify it, it will become x2 minus x1 square by pq square plus y2 minus y1 square by pq square plus z2 minus z1 square by pq square is equal to 1. So what does that mean? That means x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square is equal to pq square. Clear?
Yes.
Any doubt?
No.
Okay. So this is the final equation.
You take square root of that.
So this is the final equation, to find with the direction cosine of a line passing through 2 points. Okay. So the direction ratio of a
Here
line segment,
PQ will represent distance
between 2 points.
Yes.
Yes. So if you know the coordinates of 2 points,
it's like
in
distance
space,
formula.
distance formula only. Distance formula only.
Okay.
So x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. The square root, that is the distance. Okay. So direction ratios of a line segment passing through P and Q can be taken as x2 minus x1, y2 minus y1, z2 minus z1 or x1 minus. So those are direction ratios. Okay. So I have told, like, what is, if somebody asks you what is the direction ratio, it is nothing but that proportional line, line proportional to the angle.
That proportionality constant.
Proportional. So it is nothing but x2 minus x1, y2 minus y1, z2 minus z1. Those are the direction ratios. So if you multiply direction ratio with cos alpha, you will get the actual value.
Distance.
Right? Actually, yeah. In that direction.
In that direction, we get.
So, okay. So we will solve a few examples. So you take a picture. We will just solve 3 simple examples. So after this today's session, we will get into plane. Okay. So what we are doing today, basically the extension of what we have studied in vectors. Okay. What we are studying today is just the extension of what we have studied in vectors. What we are studying today is just the extension of vectors. Okay.
Okay.
So we'll do some simple numericals based on this. We'll do some very simple numericals. So you can practice as many numericals as possible. These can come in your CET or main JEE or what. Yes. So the main intention is to understand the basics. Once you understand the basic, you can solve n number of numericals. Yes. Okay. So all numericals are to solve any numerical, you need to develop the understanding. Once you develop the understanding, you can do hundreds of numericals. They are in CET or main JEE or JEE advanced. What they are doing is they want to know how far you have understood the concept. Then they tweak it here and there, they twist it here and there and ask you. Because the person who can answer the most twisted question, he understood the concept the most, right? So it is very important what I am teaching. You should summarize it, make a note of it, make a note of the summary of formulas, practice at least 5 to 10 numericals on that on the same day, not on the next day. If you do it on the next day, you will forget. So anything that is being taught, you should do it on the same day. Otherwise, next day, it is very likely that you will forget. the question is if a line has a direction ratio, okay. So a line, if a line has direction ratio,
A,
2 minus 2 minus and minus 2. So A, so your A is 2, B is minus 1, C is minus 2.
B
Okay.
is minus
So these are the direction ratios. Okay. Determine its direction cosines. Okay.
Alpha, cos alpha,
So
cos
alpha L is equal to cos alpha is equal to A by A square plus B square plus C square. Right? This is what we have done.
2 by
right?
2 square plus 1 plus 4.
So
Two
these
by four
are
plus
so
four
these are the formula for so knowing the so
Two by
it is there in your book. Okay, it is being
Yeah, I
given.
know.
L is equal to A by. So knowing this, I can find
Two by
out.
three.
Similarly, alpha, beta, so L, M, and N. L, M, M is cos beta, N is cos gamma. Okay.
It's the same as x by x square plus y square.
Same. A square, B square plus C square.
There we were directly taking
हाँ,
coordinates.
C by A square plus B square plus C square. So this gives you the direction cosine. Okay. Then find the direction cosine of a line passing through 2 points. Okay. So my 2 points, point 1. Okay. Point 1 has coordinates x1, y1 and z1. Okay. So it has some coordinate. Okay. Its coordinate is minus 2, 4, minus 5. Minus 2, 4, minus 5. Okay. Then I have another coordinate x2, y2 and z2. Okay. Its coordinate is, let us say 1, 2 and 3. Okay. 1, 2 and 3. So my job is to find the direction cosines. Okay. So I have told you like direction cosine L is equal to cos alpha is equal to x2 minus x1 minus x1 by pq, right?
Yeah.
PQ, because this is what we had drawn. So there is a line called PQ. Okay. So it will have different angles like the alpha angle, it will have x, y, z, it will have beta angle, it will have gamma angle. So cos alpha is equal to x2 minus x1 by PQ.
Yeah.
And then beta is equal
PQ will be there everywhere in whichever plane you are
yes.
taking, that you have to take.
L, M and N. L, M and N.
If it's
This is
alpha
cos
x
beta is equal to y2 minus y1 by
by
PQ.
PQ.
So PQ is the distance, it will be everywhere. Then N is equal to cos gamma divided is equal to cos gamma is equal to Z2 minus Z1 by PQ. Okay. So these are my direction cosines.
Yes.
Okay. So what is PQ? PQ we have already known. PQ is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root. Right? That is in the previous thing also we have done this. So it is almost similar to what we have done in vector.
Yes,
Okay.
understood.
So this is you know PQ, you know x2 minus x1. So what is x2 minus x1? x2 minus x1 is nothing but minus 2 minus 1 which is minus 3. Right? Right?
Yes. No,
Sorry, 1 minus minus 2.
1
1 minus minus 2
3.
is equal to 3. Okay.
2 minus 4
Similarly,
minus
y2 minus y1 is equal to
minus
2
2.
minus 4 is equal to minus 2. Okay. Then z2 minus z1 is equal to
3
3
minus
minus 5
3 plus 5
is
is
equal
equal
to
to 8.
8. So you know all these things. Knowing this, you can find this equation. So PQ is equal to, now you know x2 minus x1 is 3 square plus y2 minus y1 is minus 2 square plus z2 minus z1 is 8 square. Square root, so 9 plus 4 plus 64. So 64 plus 9, 73. 73 plus 4, 77 square root. So this is your PQ. So what is your L? L is x2 minus x1 by pq. Okay. So you know your x2 minus x1 is equal to 3 by square root 77.
Okay.
So this is your alpha L, then your m is
So this is direction cosine in terms
direct.
of in terms of direction ratio.
Yes, yes.
That was in terms of coordinate of x and y.
Yes, yes.
Okay, understood.
So this is m. Then m is y2 minus y1,
Minus
which
2
is
by
minus 2 by square root 77. Then n is equal to 8 by square root 77. So knowing two coordinate of 2 points, you can find the direction cosines. So this is another one. Okay. So you have some 7 to 8 numericals here. Okay. So we'll stop it here. You just try to solve these numericals and direction cosines. Then next we'll go to like the distance between two lines, how to find distance between two lines and angle between two lines. Those are all again the concept of dot and cross product in vector. How to find the angle between two lines, how to find, like say we have done cos theta is dot product divided by same thing. The angle between two lines, suppose you have two lines you have with coordinates direction ratios a1, a2, a3, b1, b2, b3 with those direction ratios. So your angle between two lines will be a1, a2, b1, b2 and c1, c2 divided by a1 square plus b1 square plus c1 square.
By pq.
Square root. Square root a1 square plus b1 plus c1 square into square root a2 square plus b2 square. That one. So what we have done in cross dot product and cross product to find the angle, similar things you will apply it here also. Okay.
Understood.
So the angle between two lines, minimum distance between, distance between two lines. How do you know distance between two lines? Distance between 2 points very easy to say. But distance between two lines means it is the minimum distance.
Perpendicular distance.
Perpendicular distance. So how to find that?
Minimum distance means the
perpendicular distance. So how to find that? So equation of a line passing through two given points. How do we have done it?
Points are
and derivation. Okay, angle between two lines. Then
derivation for line and plane is there.
Then shortest distance between two lines. So these three concepts we will cover in the next class. Okay. Distance between two skew line, distance between two parallel line. Okay. These are simplified form. Okay. If you know the distance between two lines, distance between two parallel lines will be more simpler. So
it's the same formula but some condition.
Actually, you can refer it and you can solve problems. It is not a big deal. Okay. But still, I'll explain it in another 15-20 minutes next class. Then we'll get into the plane. Okay. Okay. Thank you.